Okay, I have tried to solve this question maybe like on 5 different occasions, and I've not been able to do so because it's just really confusing. So let's read it. I get it, but at the same time, it just it sucks. Anyways, 543 diameter of a binary tree. Given a binary tree, you need to compute the length of the diameter of the tree. The diameter of a binary tree is the length of the longest path between any two nodes in a tree. This path may or may not pass through the root. So it is determining, basically the way to do this is to, it's counting the edges, these little lines here. So it's not counting the numbers. So 1, 2, 3. It's 1, 2. So if let's say this part, this 3 didn't exist and it was just this line, so it'd be 1, 2, 4 or 1, 2, 5. It would just be diameter of 2. That's it. So yeah. Okay. First things first. Edge cases. Um, So if root equals null, we'll return 0. Or if root dot, or if no root dot left and no root dot right, we'll return 0. So this is no root dot left, root dot right. And then this is no root. Cool. Alright, so here's the stupid part. So we have our max here that we're keeping. And then it's really not intuitive at all how to solve this. You need to like keep track of this and then like create a function inside of here and then call this function and then you're good. So so we are getting the depth basically, and we'll have this equal to root. Okay. So alright, so basically how you calculate this is you find the depth of the left side, the depth of the right side, and you add them together. That's pretty much it. So here the depths are 0 for 5, and then you go up here. We also check 4, so 0, 0. So you go here, and then it's 1, 1, basically. 1 on this side, 1 on this side, so you add them together. So this diameter is 2, but we also want to, so that would be like a max, but we don't want to confuse the diameter with finding the depth. So that's why this needs to be outside. So this still has depth 1. I'd explain that really poorly. So I'll write it out. So you're checking which has the higher number here, the right side or the left side. In this case, it's equal. But when we go up to number 1, this has a depth of 1, and then this has a depth of 2. But since it's the root, we add them together or something like that. I don't know. It's really confusing. It's not a question that I like. It's probably my least favorite question that has like a good like ratio. This one, just because if it was just counting nodes on the left side and the right side, I think it'd be a lot easier. And just the way that you need to like have functions inside a function and then keep track of this max. Not a fan. Anyways, okay, so I'm sure I'll have to look up the solution again, but I'm like visualizing it. Also, just a note, I hope I never get asked this question in an actual interview. That'd be amazing. Okay, so if root dot, or if root equals null, then we return 0. Otherwise, we return math dot max of left and right. Let left equal depth of root dot left plus 1. So this is actually a problem I've solved before, finding the depth of a binary tree. But you actually need, it's like a sub-problem of here. Okay. And then at the end, I think we have access to max. I think. I will check though. If left plus right is greater than max, max equals left plus right. And then I think I call depth root plus 1 or something. I think I need, okay. Let left equal depth of root dot left plus 1. Yeah, and then let right equal depth of root dot right plus 1. And then left plus right plus 1. Or something. No, we want to return max. That's just the depth. Okay, let me just visualize this for a second. So, okay, max equals 0. So this is for like sub trees or whatever. So not the root. And then we are returning the depth here. Right. We're only figuring out the depth in this part, and then if left plus right is greater than max, max equals left plus right. There's going to be some issues here, because I've seen like like setting this to, you subtract 1 and then you add 1 or something. Also, I don't need this. I can just do this. Alright. I'm going to run the code, see what happens. I don't know if you have access to max here. Oh, right, okay. 1, 2, 3, 4, 5. What does this look like? Looks like that. So it's the same question we have. It's this, basically. Cool. So that's wrong. Let me think here. At least max is being updated. Seems like I'm off by 2, so I'm thinking these are incorrect. Because it adds 1. So 0, okay, this is 1, 1. It's actually 0, 0, so this becomes 1. And then it goes up. Huh, why is this? I'm confused. What is it returning? I just want to see this. Two and one. Output is 3. Okay. This might be right. Okay, sure, I'll take it. But in this case, right. So now it doesn't go through the root. It goes through this. So, yeah. And then the depth of this tree is 2. See what happens. Will this be right? I'll be damned. I think it worked. Yeah, I couldn't get this one before. Alright. Let's go. Please work. Yes. Nice. Look at all that memory. I don't even care. Feels good, man. Feels good, man. Finally. Okay, cool. I'm actually very happy with this solution because I have a solution, so that's good. And it's basically this. I don't know why they do -1 and +1 here. I still don't get that. But yeah, and then the way to set this up in JavaScript is a little bit different than Java, but yeah, apparently you can have a variable up here, and like these are just these little intricacies and random things that you'd never know, that you can declare a function in a function, call it, and then still have access to a variable outside. That's important because otherwise we'd only have access. I would need like a helper function and all this. It would be nuts. But yeah, okay, cool. Yes, this problem's been giving me issues for like 2 weeks now, so finally got it. And yeah, okay. Thanks for watching. Hooray! Diameter of a binary tree is complete.